Okay, so in this lesson, part one of negative exponents, the first part is going to deal with just trying to understand what negative exponents are and how to deal with basic negative exponents. So first of all, we got to review the quotient rule. So remember, the quotient rule stated that when you divide like bases, you subtract exponents. So for example, if you have x to the eighth divided by x cubed, then I'm dividing like bases. I can use the quotient rule. So I subtract the exponents. So it'll be x to the 8, subtract 3, so that's x to the 5th power. Now if I had this, if I had x to the 4th power divided by x to the 7th power, then that would mean the same idea using a quotient rule. You would say x to the 4th subtract 7, and this time I get x to the negative 3rd. Now, as we go through this lesson, we want to make sure that our answers contain no negative exponents, contain only positive exponents. So, we got to we got to determine, well, how we're going to rewrite this so that way it doesn't have a negative exponent. So that's going to be the goal for part one. Well, let's look at what x to the fourth means. Let's look at the definition of x to the fourth. Well, x to the fourth means x times itself 4 times. And then x to the seventh means x times itself 7 times. So I'm going to have 7 factors of x. 4, 5, 6, 7. And then reducing, dividing out the common factors. Remember, when you reduce, remember this right here, 3 divided by 3 is 1 over 1. 3 and 3 are both divisible by 1, so 1, 1, that's where this came from, which is just 1. So same idea, x over x is 1. When you divide out the common factors, you get 1s in there as factors. And keep on doing this, just like this, and then that's about all you can do. So the numerator, you have 1 times 1 times 1 times 1, which is 1, and the denominator, 1 times 1 times 1 times 1 times x times x times x is x to the third power. So then we see this. We see that these right here were the same, so therefore these right here should be the same. So that means that x to the negative third is the same thing as saying 1 over x to the third. So whenever you have negative exponents, so if you have x to the negative third, then by definition that's 1 over x to the third. So if I have x to the negative fourth, then by the same idea, that will be 1 over x to the fourth. So the negative exponent rule says this, that if you're looking at x to the well, let's do a to the negative n power, then that is equivalent to 1 over a to the n power. Okay. Now let's look at this. Suppose I have 1 divided by x to the negative third power. Suppose that I have this fraction and the negative exponent is located in the denominator. How do I deal with that? Well, let's use the same idea. We know that x to the negative third is 1 over x to the third, so I'm going to rewrite this right here as 1 divided by, and this would be 1 over x to the third. So you have 1, and then this right here is this. And we know that from a semester ago, or 2 semesters ago, that when you divide fractions, you're going to rewrite it as a multiplication problem. So we have this 1 right here, which is 1 over 1, times the reciprocal of this, which is x cubed over 1. And so 1 times x cubed is x cubed. 1 times 1 is 1, so I get x cubed. So now we know this. We know that 1 over x to the negative third is x cubed. Now I want you to look at this pattern. So you see where the negative exponent was in the denominator? I brought it to the numerator. So to make that exponent positive, I put in the numerator. You see where, think of this as a numerator, think of this as this over 1. So you see where the negative exponent was negative? I brought it to the denominator. Now remember, you're only going to deal with the part that's being raised to the negative exponent. Now what that means is this. If you have 2x to the negative fourth power, the only thing that's being raised to negative fourth power is this base x. 2 is not, because that's 2 to the first power. This is the only one that's being raised to negative power. So by definition, that is going to be 2 times 1 over x to the fourth. And then you want to rewrite this as one fraction. Don't leave it like this. So 2 is 2 over 1. So we get 2 times 1 is 2. 1 times x to the fourth is x to the fourth. Alright, so if I had this, 3 times x to the negative 6, so we can skip this step right here and just say our fraction is going to be, right as one fraction, our fraction will be, the only thing that's being raised to negative power is negative 6, so everything else stays where it is. So 3 is going to be the numerator, and then x to the negative 6, and we write as x to the 6, where x to the 6 is in the denominator. Alright, so if I have 5x to the negative third divided by 2, again, you only look at what's being raised to negative power. The only thing that's being raised to negative power is this x, so that's what I'm going to move. Everything else is going to stay where it is. The 5 stays in the numerator, the 2 stays in the denominator. So that's going to be 5 over 2x to the third power. So this was the one I had to move. I put in the denominator with this 2. So what if you had this? You had, and again the directions will say simplify. Okay, let me write the word direction. Let me write the directions. So we say simplify. And let's go ahead and write this is number 1 for right now. This number 2, this number 3. So let's say we had number 4. Let's suppose we had 5 to the negative second power. Now, a common mistake people make is they want to say that's a negative 25. That was a mistake. Mistake is they want to say that's going to equal negative 25. That is not true. All right. So the negative exponent here does not say square 5 and then make it negative. That's not what that says. We got to use our negative exponent rule. So we have to use this. So according to this, that's going to be 1 over 5 squared. So that's 1 over 25. Okay, number 5. Suppose you had 2 to the negative 1 plus 4 to the negative 1. All right, well, let's just take each term individually. 2 to the negative 1 is 1/2, plus 4 to the negative 1 is 1/4, and then you just add these fractions by finding the LCD. So the LCD is 4. So you say 2 times 2, 1 times 2 is 2. So 2/4 is equivalent to 1/2. And these denominators are 4, so that means the numerators have to be the same. So that has to be 1. So the answer is 3/4. Alright, now what about, alright, so let's look at this one. Number 6. Suppose you had 3 divided by x to the negative 8. Alright, so again, the only thing that's being raised to negative power is this variable, and it's only located in the denominator. So remember that the negative exponent rules. Alright, so let's look at the first one. The first one, this is the number 1. First one said a to the negative n is 1 over a to the n. The other one said 1 over a to the n, negative n. 1 over negative n, 1 over a to negative n is a to the n. Again, our same discussion. If the negative exponent is in the denominator, you bring it to the numerator and make sure your the sign of the exponent changes. If it's negative in the numerator, you bring it to the denominator. So over here, this is the one that I'm going to move to the numerator. So I'm going to get 3x to the 8. Alright, so then let's look at number 7. Number 7. We have x to the negative second divided by x to the negative third. Well, we can, what the best thing to do here, first of all, is use the quotient rule, since I'm dividing like bases. So that becomes x to the negative second minus a negative third. And so that becomes x to the negative second. And remember, when you subtract a negative number, that means the same thing as adding the opposite. So subtraction means adding the opposite. So I'm going to add the opposite of negative 3, which is 3, and then negative 2 plus 3 is 1. So I get x to the first, which is just x. Okay, 8. Suppose you had x to the negative 8 divided by y to the negative third. Now be careful, don't make a mistake and subtract the exponents, because those are not, you can't use a quotient rule here since those are not like bases. So here you use a quotient rule, here you did not. So basically you can just use our properties about if it's negative in the numerator, you bring it to the denominator. If the exponent is negative in the denominator, you bring it to the numerator. So look at this, x to the negative 8, that's in the numerator. So I'm going to put in the denominator. Y to negative third is the exponent is negative in the denominator, so I'm putting it in the numerator. And that's all you do. That's it. Number 9, suppose you had x to the negative 8 divided by x to the negative second. Alright, now again, it's like number 7. You're dividing like bases, so you subtract exponents using the quotient rule. So that's x to the negative 8, subtract a negative 2. So that's x to the negative 8 plus 2. And negative 8 plus 2 is negative 6. Okay, you don't want any negative exponents. So that becomes 1 over x to the 6. Alright, number 10. You have 4 to the negative third power divided by 3 to the negative second power. Alright, so again, rewrite it. So 4 to the negative third, I'm going to put in the denominator, and the exponent becomes positive. 3 to the negative seconds in the denominator to make the exponent positive. You put in the numerator, and then you just simplify the 3 squared. So 3 squared is 9. 4 cubed is 4 times 4 times 4, which is 64. Alright, now let's look at 11. Suppose you had 2 thirds raised to the negative third power. 2 thirds raised to the negative third power. Now, the best thing to do is to use the power of a quotient rule. So remember, the power of a quotient rule basically said this. You're going to take the numerator, raise it to that power, take the denominator, raise it to that power. So that's 2, I'll do this, 2 to the negative third, divided by 3 to the negative third. And now that looks like number 10. So to make the exponents positive, 2 to the negative third will go in the denominator. So it becomes positive 3. And then 3 to the negative third, put that in the numerator, becomes 3 to the third power. So that's 27 divided by 8. Alright, now, alright, let's look at 12. Suppose you had z divided by z to the fourth, negative 4 rather, z divided by z to negative 4. Since basically the same, just use a quotient rule. It's probably the best thing to do. Now, there's another way I'm going to show you, but use a quotient rule. So you're going to say z to the first minus a negative 4. So that's z to the first plus 4. So that's z to the fifth. Now, you could have done this. You could have done this. So I'm going to just rewrite this over. So make the exponents positive first. So since z to the negative 4th, the exponent is negative in the denominator, you're going to bring it to the numerator. So you have z to number, but it's all going to be products now. So z times z to the 4th. When you multiply like bases, you add exponents. 1 plus 4 is 5. Alright? And you could have done the same thing with number 9 right here. So I'm going to go ahead and rewrite number 9 just to show you. So remember what we did in number 9, though, we were dividing like bases, so we just used quotient rule. For number 9, you could have also, let me write this in 13. You could have also said, well, I'm going to rewrite this negative x1 and bring it to the numerator, so you get x to the negative 8 times x to the second power. And then when you multiply like bases, you add exponents, so that's x to the negative 6. And that's what we got here. And so that's just 1 over x to the 6. That's another way of doing it. Most students, though, just prefer to use the quotient rule. So we divide like bases, the quotient rule. But again, here, you could use the quotient rule, so you had to remind yourself, well, since x to the negative 8, that exponent is negative in the numerator, bring it to the denominator. And over here, since the exponent is negative, bring it to the numerator. All right, let's look at 14. Suppose you had 2x to the fourth power divided by y to the negative third power. So again, the only thing being raised to negative power is this y. So I'm going to bring it to the numerator. So it becomes 2x to the fourth. Everything else stays where it is. So 2x to the fourth times y to the third. 15. Suppose you had 4x to the sixth divided by 3y to the negative fifth instead. So again, the only thing being raised to negative power is this y, so that will bring it to the numerator. Everything else stays where it is. The 4 stays where it is, the 3 stays in the denominator, the x to the 6 stays in the numerator. So I get, that's the only thing I'm going to move. So I'm going to get 4x to the 6th, y to the 5th, divided by 3. So I'll leave it as one fraction. 16, if you have 5x to the negative third divided by 2y cubed. So again, the only thing being raised to negative power is this x, so I'm going to bring it to the denominator. Everything else stays where it is. So 5 is going to be the numerator, 2y cubed, x to the third in the denominator. Now, we prefer to put this in alphabetical order, so you could have written it as 5 divided by 2x cubed, y cubed. Either one of those is fine. Okay, so that's going to take care of this lesson.